So up to now we've been focusing on keeping our amount of gas constant. And so we're finally going to address this. And you may remember Avogadro. Avogadro gives us a number, 6.022 times 10 to the 23rd molecules or atoms per mole or anything per mole. And he actually came up with that work while doing his research on gases. And so he was a big player in gases as well. And so it's not a surprise that he also did mole work in gas research. So Avogadro's law tells us that, okay, so this is like the fourth law we've learned, right? So make sure that you've got those separate and you know what they each talk about. When the pressure and temperature are constant, the volume of a gas is proportional to the number of moles present. That is, if you increase one, the other increases. So volume divided by moles is a constant. So I can literally change the number of moles if I keep the volume and the temperature constant. That will change the volume. Yeah, I know. It's kind of crazy. All right. If the number of moles of a gas in a cylinder is increased, then the volume of the cylinder will also increase, right? We remember that from before. So if we've seen this relationship where we decrease or we increase something and something else changes. So if we decrease the volume, if we increase the volume from 1 liter to 2 liters, if everything else is held constant, then in temperature and pressure, then we will, instead of 1 mole, we will have 2 moles. It's crazy, I know. All right, this behavior is described as V1 over N1 equals V2 over N2. And so oftentimes we are going to compare gases at what we call standard temperature and pressure. Standard temperature and pressure, it's abbreviated as STP. And STP conditions are 1 atmosphere pressure and 273 Kelvin. And remember, 1 atmosphere is the same as 760 millimeters of mercury, and 273 is the same as 0 Kelvin. So at STP, 1 mole of any gas, this is from Avogadro, has a volume of 22.4 liters. Always. So we call that the standard molar volume. Okay? It has to be at 1 atmosphere of pressure and 273 Kelvin. So those two things are constant, all right? And so then we know that the mole of gas is going to occupy 22.4 liters, and that's called the standard molar volume. So remember that different masses are going to be different moles. Like it takes 28 grams of nitrogen gas to make a mole. It takes only 4 grams of hydrogen gas to make a mole. But it's 6.02 times 10 to the 23rd particles for both of those. Okay? And so we have the same number of particles. Therefore, according to Avogadro, they take up the same volume. So 1 mole of that many particles takes up the same volume, but that's a different amount. 28 grams versus 4 grams. So again, we can use this to work problems, and how many moles, for example, how many moles are contained in 2 liters of nitrogen at STP. Now from now on, when you see standard temperature and pressure or you see STP, you know that that means 1 atmosphere and 273 K. You know that now. So sometimes it'll look like you may not have enough information, but if it says at STP, it's actually telling you a pressure and a temperature. All right, so you've got 2 liters of nitrogen. How many moles of nitrogen is that? We know that there are 22.4 liters per mole, and this is a conversion, so we can flip it upside down. And so we have 2 liters, and 1 mole is the same as 22.4 liters, so we can cancel liters, and that'll tell us that we have 0.089 moles of nitrogen gas. Not too hard, right? So you just need to remember that molar volume. Thank you, Avogadro.